JAH, the science guy. JAH, the science guy.
Oops. What am I supposed to do?
Call JAH.
I know, I'll call JAH. Hello?
Hello?
Okay, bye.
Okay. Hi, JAH here.
Oh, I'm so glad you came.
Oh my god, an acid spill. Don't worry, I got you. And my textbook. There's a certain thing. This is relax. It's an acid neutralizer, so what we do here, really simple. Just take this, just go. Oh my god, it's acid neutralization. Whee!
Acids and bases.
Okay, so what's an acid? An acid is something that tastes sour, conducts electricity, and it has no feeling. You can't tell if it's an acid unless you taste it and it tastes sour. So and a base tastes bitter and it's slippery, like the soap you wash your hands with every day. Acids and bases. An acid gives away hydrogen. The base takes the hydrogen. Water can act as both acid and base. It can either take the hydrogen or give away one of its hydrogen and become a hydroxide. So, when an acid gives away its hydrogen, it becomes a conjugate base. And when a base takes the hydrogen from the acid, it becomes a conjugate acid. So what happens when an acid and a base are mixed together? Well, they neutralize and they form a salt and water and some gases. Well, I'm going to mix soap, which is a base, with some acid. Wait a minute, I don't have an acid. Okay. Thank you. Okay. So, when I mix these two together, what do I get? Let me see. I get salt!
Before we start our experiment, we're going to talk to you about the pH scale. Okay, so from number 7 to 14 is bases. The higher you go, the more basic something is. For example, household ammonia is number 12, which is more basic than ocean water, which is number 8.
Acids range from 7 to 0, where 6 here, which is milk, is less acidic than lemon juice. And 7 itself is just neutral, like water.
Miss.
Yes,
I
John.
have a question. How could you tell the difference between an acid and a base?
Well, just go get yourself some litmus paper.
This is red litmus paper.
This is blue litmus paper.
It doesn't really matter what color litmus paper you get, because bases will turn litmus paper blue and acids will turn them red. Okay, so time for experiment.
With your pictures hanging on the wall, is this the way it's meant to be? Only dreaming that you're missing.
As you can see, the bases have turned the paper blue, while the acids have turned them red.
This is lemon juice. It's turned the paper red. This is water. Water is neutral, so it did not change at all. And soap is basic, so it turned it blue.
Bases rule. So do acids. Try this. Have you ever wanted to know if anything was an acid or a base? Well, now you can with your own litmus paper. Things you'll need are red cabbage, a pot, some hard paper, and some scissors and water. And a stove. First, turn on the stove and pour in some water. While the water is boiling, rip up some pieces of red cabbage into small pieces and put them into the pot. As you can see, the water has turned purple. Now, take the pot and pour the water out, getting rid of all the cabbage. Now you can clearly see the purple color in the water. Now put the bowl away and wait for it to cool down. And as you do so, you can cut the piece of paper into as many strips as you want. Okay, put the papers into the water and wait for them to turn purple. Now you can take the pieces out and let them dry.
While you're waiting for the paper to dry, you can still indicate whether your household products are base or acid by using the juice you got from the cabbage. All you have to do is pour some of the juice to a plate. And you put some acid, like a lemon. As you can see, the juice is turning pink. This indicates the lemon is an acid. Okay, and if I add baking soda into the juice, it will turn green. This is how you can indicate whether something is a base or an acid. Bases turn green, acids turn pink.
Thank you for giving us your time today. What can you tell us about acids and bases in general?
Well, there are two types of acids and two types of bases. We have a strong acid and a strong base, and we have weak acid and a weak base. They have different characteristics. For example, strong acids and a strong base, they both completely dissociate into ions in aqueous solution, whereas for a weak acid and a weak base, they only partially dissociate into ions in aqueous solution. An example of a strong acid is hydrochloric acid. An example for strong base is sodium hydroxide. There are special ways of naming acids since they're mainly made of hydrogen. There is a prefix, which is hydro, followed by the name of a nonmetal. Then there's a suffix IC and the word acid. An example of that would be hydrochloric acid. On the other hand, we have bases which are mainly composed of hydroxides. So that's pretty much all you need to know about acids and bases in general. I hope I've answered your question. Is there anything else I can help you with?
No, that was great. Thank you.
Would you neutralize if I ask you to neutralize? Would you take away my hydrogen if I ask you to? Would you taste bitter if I tasted sour? Could you be my base tonight? I can be your acid, baby. I can light a bulb for you. Oh yeah. I can clean your pocket change. I can burn a hole through you.
Would you neutralize if I asked you to neutralize? Would you taste sour if I tasted bitter? Would you be my corrosive if your pH was too high? Could you be my acid tonight? I can be your base, baby. I can take away your hydrogen. I can wash your dirt away, oh yeah. I can slip right through your hands.
When I put the Spillex onto the acid, the solids in the Spillex are strong bases, and they neutralize the acid, turning them into salts. Now when the salts form, it's safe enough for me to remove it and clean up the area that I've spilled. And that's about it. JAH.